of our videos for the review. They're short though, so hopefully they'll be better, a little easier to watch. Oh, that's not what I was trying to open up at all. Right now we're going to go ahead and start, I believe we're on problem 34. Let me get this opened. I know that we were doing the system of equation problems. Let me zoom out a little bit. I pushed the wrong button. So we have literally done this whole page. So actually, let me go ahead and get rid of it. And then we can move right here. Okay, awesome. So let me flip my laptop. I'm going to zoom out so I can delete all of this. Those are the last problems that we completed. So that means that we are on problem 34. Okay, problem 34 says the Family Fine Arts Center charges $20 per adult and $12 per senior citizen for its performances. On a recent weekend evening when 468 people paid admission, the total receipts were $6,480. How many who paid were seniors? Okay, so what we're going to do is we're actually going to create our own system of equations. We're going to look at, okay, let me just write it here. It'll be easier to say this. Okay, so we're going to look at the $20 tickets as X. And so these are the adults. And then we're going to look at the $12 tickets as Y. And so these right here end up being your seniors. Okay, so if we're going to use X for adults and Y for seniors, we could actually create an equation that, okay. This is actually the second equation. I probably should have said this sentence second, but I'm going to go and say it, and then we'll just add the first one. We're going to actually create an equation using this information. We know that there were X amount of people who paid $20 per ticket, and there were Y amount of people who paid $12 per ticket. And we also know that the total amount of tickets sold, that they amounted to 6,480, right? So that's one of our equations. The first one, I mean, I don't really think it matters which order you put them in, but I prefer it this way. Our other equation is going to come from the total amount of tickets that were sold. They told us that they sold 468 tickets, correct? And we know that that's going to be a combination of adult and senior tickets. So that's where you get your two equations from. So we just have our simple two variables are going to total the amount of tickets sold. And then we're going to have the different prices with the variables, and that's going to actually total the amount of profit or the amount of money that was made. And I know that these are going to go with this because 20 and 12 is the amount of money that they collected for those tickets. Okay, so now we're just going to go ahead and solve it. I think I'm going to go ahead and do the substitution because I definitely don't want to multiply that by 20 or actually a negative 20 and do the addition method. So I'm just going to go ahead and I'm going to solve that first equation for X, which means I have 468 minus Y. And then now what I'm going to do is I'm going to actually plug that equation into my other equation, equals 6480. And then right here, I'm going to go ahead and do distribution. If you do 20 times 468, what you get is 9,360. And then if you do 20 times a negative 1y, you get a negative 20y plus 12y equals 6480. And then I'm going to go ahead and combine the like terms on the left-hand side and move my 9360 to the right-hand side. What I end up getting is a negative 8y equals a negative 2880. Now what I'm going to do is divide both sides by a negative 8, and I get that y equals 360. Usually most problems right here, what we would do is we would take this y and we would plug it into another equation. But if you read the problem, right, always make sure you read the problems, follow directions. It says how many who paid were senior citizens. We declared y to be our seniors that paid at $12 per ticket, and we just now solved for y. So there were 360 seniors who attended the Family Fine Arts Center that night. Okay, so let's do problem 35. I'm going to go and read it, and then I'm going to scoot down here. I'll just delete this one. Okay, so let's do problem 35. It says a vendor sells hot dogs and bags of potato chips. A customer buys 4 hot dogs and 4 bags of potato chips for $11. Another customer buys 3 hot dogs and 2 bags of potato chips for $7.25. Find the cost of each item. So obviously, because it said to solve using a system of equations, that kind of lets me know that I need to declare, what is my x, what is my y, and then set up my equations. So what I'm going to do is I'm actually going to say that hot dogs is x, and I'm going to say that potato chips is y. Honestly, they appear in that order, so it makes sense in my head that they would, hot dogs would be x and potato chips would be y. And then now let's go and look at the sentence. It says a customer buys 4 hot dogs and 4 bags of potato chips for a total of $11. Then another customer buys 3 hot dogs and 2 bags of potato chips for $7.25. There is your system of equations. Now let's go ahead and solve it. I do not want to use substitution because if I tried to solve for one of these variables, I'm going to end up having to divide by either 4 or 3 or 2, which is going to give me an ugly fraction. I'm not trying to plug that back in. So instead, what I want to do is addition for this system. And I noticed that there's a common multiple of 12 between 3 and 4. And so I actually want to make both of them right here, both of these coefficients 12. I do want one to be positive and one to be negative. So what I'm going to do is I'm actually going to multiply my top equation by 3, and I'm going to multiply my bottom equation by a negative 4. And what I get whenever I do that, let me just go ahead and show. These are new equations right here. If you distribute that 3 in, you're going to get 12x, and then you're going to get a positive 12y, then you're going to get 33. Then if you distribute that negative 4 in, you're going to get a negative 12x. You're going to get a negative 8y, and then you're going to get a negative 29. And so here, because I'm using the addition method, right, what I do is I just notice that those are additive inverses and they go away. That's great. I'm going to actually do the work right here. If you combine a positive 12y and a negative 8y, what you get is a positive 4y. If you combine a 33 and a negative 29, what you get is 4. And then dividing by 4, I get that y equals 1. And y was what? Y was the cost of my potato chips. On my, this is the freaking review that I sent y'all. I accidentally said that y were the hot dogs. So I apologize for that. Okay, so this right here, let's go ahead and we could do this. We could say this is our potato chips. If it's an answer, we could put it in red. And then what we're going to do is we're going to actually go ahead and plug this y equals 1 into an equation. I'm going to pick the easiest one, and I believe that the first equation is the easiest equation. So what I'm going to get is 4x plus 4 times 1 equals 11. So what I get is 4x. I'm actually going to move that 4 over, and I would get a 7. And then I would divide both sides by 4. And then I would enter it into my calculator, and I would get the decimal. I would get 1.75, right? We put it in decimal order. That way it looks more like money. And this right here would actually be the cost of our hot dogs. And so if you did put this into an XY form, which, I mean, just, saying which ones are the hot dogs and which ones are the potato chips would be fine. But if you did something like this, of course, that is also fine. Also for 34, whatever problem we did there too, there's only one answer, but I mean, if you had done something like that, that would be okay. I'm going to go ahead and do 36 and 37. And then I might even do one of them at the beginning of the next video. So I'm going to get a couple more problems on here. Okay. You know what? I'll do 36, 37, and 38 in the a video together since they're all the same thing. Okay, so if y'all have any questions, make sure y'all let me know. Thanks. Bye.